Welcome to the special edition of the Uptime Wind Energy Podcast. I'm your host, Alan Hall, along with co-host Joel Saxum. Our guest is Amin Ahmadi, technology lead with AP Renewables. And the AP Renewables is based in Ontario, Canada, our friends up north. I was first introduced to AP Renewables because of their SLPS system, which is a grounding brush upgrade kit to reduce static and lightning issues in a bunch of Gamesa turbines. So it basically gets rid of the air gap you see on TikTok and on LinkedIn from static electricity jumping inside the turbines. They also have a new product now called SCADAScope, which provides insights and diagnostics for Gamesa and a bunch of other turbines. And so we're really interested to hear what Amin has going up in Canada. Amin, welcome to the program.
Thank you.
Let's talk about the lightning issue that the Gamesa turbines had and the little spark gap they built into that wind turbine and what it means to the SCADA system, because it did cause a lot of problems.
Yeah, we started in fact as a consulting, and we started noticing a similar problem coming up. Different problems having these phantom noises, and I don't have a lightning background like you do, but I saw the problem from random, unexplainable electronic faults and SCADA and comm losses that could only be mapped over weather events. And then you go back to building codes and other things. It's like you got a lightning system, you got to ground that thing really, really good. And this particular design wasn't grounded really, really good. So we decided to take the we decided to sort of solve a bunch of problems through a single common design, which was a brush that installs quickly and makes a lot of problems go away. And what we liked about it was how very quickly you get a lot of gain. The return on investment was huge on it. And to be honest, I designed a very elaborate thing. I sent it to a wind farm we work with. He's like, this is not installable. And my partner, who has a design background, not engineering, he looked at it and is like, this is bad. This is bad. And he made it into, so revision 2 took about 15 minutes to install. Revision 1, which I had designed, didn't get installed in three hours. So that was how the team came together to really make these things work and work well and work outside the paper, which sometimes is a great place to design things.
Yeah. So the design, what it does is it takes electricity, static electricity or lightning from the blade to the hub without having a big spark gap. Because every time there was a discharge, a significant discharge in the kind of in the cellular area next to electronics, it upset the electronics, it upset the SCADA system, and the turbines would alarm, right? They would alarm and sometimes shut down for no apparent reason.
Yeah, you basically charge up the blade as a capacitor, and eventually you breach the air gap and you dump that surge of current, and the grounding is disturbed enough that the electronics would just fault out for some random reason, because 200,000 amps is going through the ground now.
It can, yeah. And I think that was a really good catch, because I think a lot of people wouldn't have identified the connection. Like, what's the true cause? Let's get out of first principles here. Hey, it's static electricity. It's lightning strikes. We can fix that.
Yeah, a couple questions with the SLPS system. So you guys are still you've been installing them for years. You're still installing them today. And is this a system that only works on that 2 megawatt Gamesa platform, or is there other systems that have this same issue out there in the world?
It seems like the funny design has gone on to the newer generations. We have an upgrade for the G114. We could design it for the newer ones, but the OEM has been promising the owners that they're just going to issue their official release. So the novelty wore off for us. But if an owner really wants to just go beyond the OEM and solve it themselves, we'd be happy to sort of bring that technology and adapt it to the mechanics of the newer generation. But it's a very bizarre problem that doesn't exist on other platforms.
That's right, because they don't have that spark gap built into the system, right? Because they learned a lesson early on, and there's a lot of Gamesa owners out there that don't know that is happening, that they're getting tripped offline because of static electricity. And so there is a solution out there, and I think this is a good platform to let everybody know, like, if you have trip off, you don't really understand why, or if you have a lightning storm come through and a lot of your turbines are tripped off, it's an SLPS fix, right? You need to call Amin here and get this thing resolved, because it's a very simple problem to solve.
Yeah, give us a call.
So let's get to the next generation of products here, which is SCADAScope. So I assume the Scatoscope is derived out of all your Gamesa work and being involved in wind turbines. There's a lot of issues with wind turbines. The diagnostic is not so good. The troubleshooting tends to be a little bit random, and you go to different, I know I've been to different operators. They have the same wind turbine. The way they shuttle through and try to troubleshoot a code is completely different. Everybody's got their own little playbook for it. Some of them have great playbooks, some of them not so great playbooks. You're trying to take some of that mystery out of that system with SCADAScope, right?
Exactly. It's a bit of an art, and we want to make this into a science. And honestly, there was a lot of focus on like condition monitoring and whatnot, but we sort of have tuned the system, and we are focusing on this reducing the mean time to recovery. You want to get there, you want to know what's wrong, and you want to fix it. Because ultimately, a SCADA alarm, when it's even good, it's just a symptom as detected by a relatively slow PLC. And a SCADAscope allows you to have the fault data and then sort of compile together various potential causes. And even if you don't know exactly which one of the three things caused the actual downtime, you have a path forward. A technician has a path forward. And a lot of it comes like, it's just how new the industry is and how new the workforce are. So I think we can sort of help with that too. If everybody was the master of it, yeah.
Yeah, that's a really good point. I mean, because the experience a technician has does get to a faster solution, but those people can be hard to find. To have a person that understands that particular turbine really deeply can be a hard person to go get, right? And they do exist, and I've met a number of those people, and they're geniuses. But you like to communicate that same information to the rest of the crew. How do you do that? I think you need a tool like SCADAScope to help diagnose, right?
We talk about this in the industry a lot. We've been talking about it on our main podcast as well. And you hear Vestas talk about it, hearing Siemens talk about it now, and even some of these major investors. Guys, we need to slow down on how many new models we're putting out there. We talked to someone the other day that was talking about a specific OEM, and they said, yeah, you may, from the outside looking in, you may see this as the 2.65 megawatt machine, whatever. But there's like 300 different iterations that you can option out for that machine based on where it is on the grid and what kind of blades it has, low wind speed, high wind speed, this, that, the other thing. So you not only do you have a lack of technicians that have been in the industry for a long time knowing these problems, but you have new machines coming out constantly, or we have had for the last 10, 15 years, new machine after new machine after new machine after new machine. And so many of these issues are just like, you don't have the capability of learning all of these things and having all of these technicians that have this knowledge in them. So what SCADAScope is doing is trying to pull from different areas and different things and basically say, hey, this tripped. Here's the path that you follow. Here's your flow chart to get out into the field and get this thing back up and running.
And I was mentioning the industry as a whole has this challenge that if a technician gets good and has 15 years of experience, 20 years of experience, they're already in their 40s and 50s. The willingness to climb goes down just because we're all human beings and our knees start giving. So we sort of, you know what I mean? Like if you're really, really good at troubleshooting, then why not just go to a factory? So that has to be considered and sort of accounted for in the tool set that the industry develops for itself.
And I think, from an industry also, I think, Joel, you raised a really good point here, is that there's a lot of turbines out there. And the ones that probably have the least amount of knowledge in, surprisingly, are some of the older turbines, because the people get shuffled through and they don't work on the cool new stuff. Everybody wants to work on the cool new turbine. However, the workhorses are a lot of Gamesas, a lot of Siemens, a lot of Mitsubishis in the United States, Acciona, turbines that are out there, where a lot of the technicians there tend to be newer, generally speaking, and those turbines can be difficult because unless you have a lot of knowledge about them, they're not the fancy new GE turbine or Vestas turbines where it's all sort of computer screeny. It's not like that at all. You need help. SCADAScope is there to help take away some of that black hole of knowledge and try to give people an understanding of what's happening, right? That's a really needed area.
Very much so. And I think the other area we have focused we have tried to make the system, make it trainable. So if one person knows, let's get that, automate that knowledge, and share that with every other technician, potentially everybody else using that platform. If you have a single turbine and 10,000 of them, statistics of experience and alarms would almost narrow down the path forward. But if you're somewhere in the 5 to 500 turbine range, that the sort of self-learning experience does not exist for not necessarily AI, but even human learning. You just don't see a failure enough in your fleet to be able to do that in ways that like is effective.
The alarms that get the most alerts, right, are the ones that everybody learns about. It's the rare one that causes the trouble and the turbine's offline. That's the one you got to go fix, right? And you don't have the tool set, the diagnostic diagram to go figure out what to go do next. Those are the ones that really eat you up because the turbine's down.
And some, like, as much as I love digging into data, sometimes the basic primitive SCADA alarms, okay, I have alarm 20 now. Yesterday I had alarm 15. That combination means this. That statistic could build up, but you need thousands of turbines and hundreds of hours of repair for that to become an effective path forward without the data behind it. But when the numbers are smaller, this is when the data could come in and really accelerate the troubleshooting.
So what are you guys having for issues of people, or are you not having issues of people sharing this data, right? Because you have to, as a hub, you have to build this data from operators, OEMs, whatever. How are you guys collecting the data and sharing it with others?
Right now, we are sort of in an early adoption phase where we are training the system. We have thrown enough domain expertise at it. And in this phase, honestly, like the system it's very easy for the system to say, operator owner A, I want my knowledge to stay with me and share with nobody else. Like technologically, that's very possible. But we have a strategic decision to make. At this point, I'm more interested to partner with someone who says, I'm willing to share my know-how and get other people's know-how. It's kind of like, I don't know, MSN Messenger. If you couldn't see my status, I couldn't see your status. But like, MSN enforce a bit of rule that if you're willing to play, then, let's play. But it goes into a cloud or stay on-premise, and the automated little fault finders could be only yours. But then you're paying full price and everything has to be developed for you in that scheme of work.
Right. So it's like going online and looking for a YouTube video to get your turbine running. That's kind of like the way it is, right? If someone's willing to share, then that makes everybody else's life down the line so much easier. And we don't have to keep reinventing the wheel. It's basically what it is, right? It's sort of that YouTube for wind turbines.
Well, that's what we've been talking about quite often here, I guess within our circles, is the lack of sharing of data, right? So if it's OEMs not wanting to share design, or OEMs not wanting to share an issue, or almost even covering up issues sometimes, then you have ISPs, right, where they're like, oh, if we work on these, we don't want to share this because it's a trade secret. But at the end of the day, in my opinion, right, there's a time when it's intelligent to work with your industry and your cohorts, because what that's going to do is bring down the levelized cost of energy for all, right? If we're able to stabilize the grid by more people being able to keep the uptime levels up, that's better for the whole renewable energy industry in general. And so that's what I see is the possibility here. If you guys open this thing up, I mean, not if you guys open it up, but if you have people that are willing to share data and be a part of the team here, get more on board, is helping. Farm XYZ helps Farm ABC, helps the people in Denmark, helps the people in California, helps the people in Canada. It helps everybody.
Yeah, and I think it's good to sort of be clear that we like the cybersecurity of the plant, that's not up for debate. We are not talking about sharing control with stuff. And I think we have a really good solution for that. And I'm sure there are other sessions you can have about cybersecurity. And aggregate business data where your investor is interested, that's also separate. We're talking about sharing not your data, but the know-how, how to use that data into a result. That's the only piece that is meaningful to share between different operators. So uh, yeah, I just want to be sort of clear between us that we are talking about that little bit of know-how, and at some level, when a technician quits operator A and goes to operator B, a lot of that know-how goes around. So trying to write policies around and say none of this is kind of impractical at many levels.
It is, and that's what leads to this discussion. Really, is how to best communicate all this information and where can people tap into it and be a resource to one another. I know, Joel, I was just on Facebook the other day. Technicians were asking about specific SCADA units and alarms on Facebook. This is the worst place for this to happen, but people would respond, right? It does become this sort of weird sort of network between technicians, and thank God the technicians are willing to go out and to give help that way. But there's got to be a better system, right? There needs to be a little more logic behind it, and that's what Amin's developing here at AP Renewables is a better system, the way to track this, what's going on, and how many wind turbines or what generic wind turbine brands are you dealing with at the moment? I mean,
It's the Gamesas, Vestas, some generations, and we are looking at Acciona and Mitsubishi's, and hopefully the older GEs. It has to do with the market, the partners we find, the numbers that exist.
those numbers are growing, I assume, because once people adapt the system and learn about it, like, oh, this makes sense. I can not only contribute to the knowledge base, but I can pull information from it, particularly on Elite's turbines, which are the workhorse of the wind industry in the U.S. and Canada. It does make a lot of sense that there should be, at this point, data.
Do you have an example or a case study where this has happened on something that you guys have worked on that you can share with us?
As I said, we are training the system, so every week there is a couple of new issues. Another one, like very interesting one, was looking at the blade imbalance, like the rotor balance growing fast. Like rotor being out of balance is bad, but we're looking at it, have a meeting midweek, is like, this turbine is growing worse every day. Oh, maybe the pitch system is detaching, and this weekend it detached. So the pitch controller came out of the blade, and it's going to do more mess than you like it on a Saturday. We just automated that. They're like, okay, rotor out of balance bad, but rotor out of balance progressing really quickly, that's its own synthetic alarm that, like, you got a pitch ram coming loose. And that's the type of thing we are learning actively. We had another one where, we just go down to anywhere between my blade bearing is like a turbine has been down for some sort of misalignment issue, or like blade getting is stuck. We can think it's blade bearing is frozen, but we can go down all the way to an intermittent loose wire in one of the safety valves. And that's the type of problem we can really go after, fix the first time problem. Because if you're looking for an intermittent cable amongst, 60 of them, your chances are pretty slim. You're going to be back in that tower very quickly. But if it's one of these two valves and it's only pitching up but not pitching down, then you're looking at 3 cables. And going back to our a scaffolding of technicians and helping techs, is like, imagine being thrown in a place with 60 wires, and imagine being in there and being told, check these 3 wires really good from one end to the other. Your probability of success are now exponentially higher, and chances are it's not going to throw that fault anymore.
And if you're in Canada and you have to spending hours and hours up in a turbine when it's really cold outside, like it is right now in the wintertime, that's no fun.
But I'd say it's just as unpleasant when it's 42 degrees outside in Texas, 42 degrees Celsius, and you're in the hub looking for a cable. Everything about your body wants to get out of there, right? So, I mean, like, physiologically, you do not want to be there.
Having the idea of where to look first is the way to quickly solve the problem. Yeah, it's instead of just thrashing around trying to identify what could be possibly going on, narrowing it down is huge, and that's what Scatoscope does. Is it narrows it down quickly. This is fascinating because this tool has needed to be around for a long time, and I'm glad you guys have finally put it together. How do people connect with you and learn more about Scatoscope and find out more information?
I think APRenewables.com is the place to start. We'd be happy to show demos of system in action. And ultimately, this troubleshooting is a product called Uptime 911. We want to give instructions to a technician heading out to the turbine. And we have examples of that and a library of faults that is ever growing. And, I was talking to an executive a month or two ago, and he's like, can you throw in some schematics there too? And the answer is absolutely. That's 2 pages with a little red thing around the input that's probably part of your intermittent circuit. He's like, I know I know my technician can find that technician, but can you just make it automatically attached to the ticket? The answer is yes. So now all our troubleshooting tickets usually go out with a few pages of PDF just in there. One less excuse or one less reason to be confused in the tower, if you like. And I name him this came from Troy Ryan. I really appreciate it. It was one of those subtle pieces that I'm like, who cares about it? They can find it if they want. And he's just like, put it in there. So it actually was quite popular. You know what I mean? It just saves the hassle, the look on the phone for thing, and it's highlighted. And I feel like once I saw it in action, instead of this page with many lines on it, somebody has focused it on the problem. So as a new technician, it's like, oh, I see that. Now that I see the cable number down on the cabinet too, it starts building confidence and a scaffold the technician. So next time in a more complex problem, they'll do that themselves because now they know what to do with it. It's a very hands-on. It turned into a very hands-on training, actually.
That is a really, really good use case. And so if you want to learn more about SCADAScope or AP Renewables, check out their website, aprenewables.com. And you can't find Amin Ahmadi on LinkedIn. Just Google search him on LinkedIn or just go to LinkedIn search and you can find him there and connect that way too because, hey, wealth of knowledge here and there's a lot of good information going on at AP Renewables right now. So, Amin, thank you for being on the podcast. This has been tremendous.
Thank you for having me.